Okay, we're going to do a couple more examples here before I let you try some of these. We're going to look at one more example where we have to solve algebraically. Okay. And the directions here are going to say solve it analytically, okay, which means we need to use algebra to find the solutions to this. Okay. We could, if it's a calculator problem, of course, we could use the graphing calculator to help us, but bottom line is if we have a cubic function, okay, we need to find the zeros. Well, we have 24 and we have 2. So if we made our list of rationals, the factors of 24 over the factors of 2, we'd have a fairly big list. True? So let's go ahead and use the calculator to narrow that list down for us. So if we do 2x cubed minus 7x squared minus 10x plus 24. Looks like negative 2 might be a 0. So let's try it and see if it is negative 2. We go negative 4, that'd be negative 11, that'd be 22, and that would be 12, that'd be negative 24, that'd be 0. So good. So it turns out that that is in fact a 0, so there's one of them. The other two are going to come from 2x squared minus 11x plus 12. Okay. It looks like this one has nice answers because it looks like another of the zeros might be 4 here. So if I do 2x and x, if I can find factors of 12, that'll give me a sum of 11 here. Be 4 and 3 would work. Minus minus. Okay. And looks like the other one goes through at 1.5, so that one shouldn't be surprising either because we'd get 3 halves and 4. Okay. Alright. So with that said, those are our 3 split points in this case, our zeros. So if I put them on my number line, negative 2, 3 halves, and 4. Okay, we'll analyze. And like I said, we use the calculator to help us here. In this case, we don't have to have a calculator for this problem because we could find those zeros without the calculator, as we know. Okay. But if we look at our test points, if we put in negative 3, let's say, for instance, okay, we would have a negative here and a negative here, which would make something positive. Okay. So again, if I were to plug in negative 3 into this, okay, I would have negative 6 minus 3, that's negative 9, and then negative 7. Okay. Something that is between these two. 0 is between these two. If I were to put a 0 in between those two, I would get something that is negative times negative, which would be positive also. Okay. And then my 3 halves and 4, if I put my number in there like 2, for instance, I would get a positive and a negative, which would make a negative. And then anything bigger than 4 would give me positive here, positive there. Alright. You know what? I forgot something. Darn it. I need my other factor in there. Sorry. Okay. So the full factorization, remember, is going to be x plus 2 out here. That's why this one's not right. Okay, this one actually should be a negative times a negative times a negative. Okay. I forgot to put my other factor on there that we found in the first place here. Okay, so we got to have all 3 factors there to figure out what the polynomial is like. Again, putting a 0 in there is going to give me positive, negative, negative, which is positive. Putting a 2 in there is going to give me positive, and this one would be positive, and that one would be negative, so that is negative in fact, and anything bigger than 4 is going to be positive, positive, positive. Okay. So with that analysis, like I said, that tells us the answer to the question here, because we want to know when is this greater than 0. Well, it's going to be greater than 0 in the areas that have positives. So it'll be negative 2 to 3 halves, and then from 4 to infinity. And that would do it. Okay. Questions on that one? So again, still all about finding the zeros. Okay, if we find the zeros, okay, then we can create that test. And when we test, the test tells us any of the answer that we want. Less than, greater than or equal to, less than or equal to. Okay. Right, and the next one I'll look at is this one. We have x cubed minus 6x squared. And the first thing that I would do here in this one is to get everything onto the same side. Okay. so that we have an inequality that looks like all the other ones that we've done today so far. So if we have this, we want to know when this is less than or equal to 0. They told us to solve this graphically. And generally, if they tell us to solve this graphically, that might mean that the zeros are not nice zeros. Okay. We could try 2 and 1 and positive 2, positive negative 1 and 2. Okay, and none of those would give us an answer here. So there would really be no way for us to break this down. So our only choice in this case is to do it graphically. So let's see what we get if we graph that. So x cubed minus 6x squared plus 8x minus 2. And again, we're looking for when is this less than or equal to 0? When is this curve below the x-axis? So it looks like it's below the x-axis up until we get to that point right there. So let's figure out what that is by using our 0 command. Looks like 0.325. Okay. So we'll do 3 decimal places. So that means negative infinity to negative 0.325. Okay. All right, and then it goes above the x-axis, and then it goes below again from that point to that point. So if we find the other 2 zeros, that one's going to be 1.461. And then it's going to stay underneath the x-axis until we get over here. So we'll find that last 0 with the calculator. Turns out to be 4.214. Okay. And the other issue that we want here, and this is kind of, we have to be a little bit careful here because we want less than or equal to. So if we're going to say that these are the zeros, these are the rounded versions of the zeros, okay, even though they're not the exact answers, okay, should we include them or not? What would you think? Based on it being a less than or equal to? So even though they really aren't the exact answers here, we're still presenting these as our zeros. Okay, so we should in fact include those. Okay, so in this case we would include them. If it had been just a less than sign, then we would not have included them one way or another. Okay, so even though it's kind of sketchy to do that because these aren't exact answers, we still are saying that these are our zeros, so we should include them. Okay. Questions so far?